If AI chat assistants are used in an academic context, an architecture is needed that ensures high data quality and compliance with GDPR and the AI Act. Here is a proposal for an architecture. Imagine a student wants to reflect on their module, economics. The end user only sees a front-end chat box embedded in their campus system, which they use every day. They know that their questions are processed by a large language model. What they do not know is the complexity of the architecture and how guardians and the operation control components use data retrieval and response processing to create a grounded, high-quality dialogue at the front end. Let's see how the AI system processes this request step by step. In the beginning, the adaptive task dispatcher determines which AI assistants and functions the student can access. The access and quota controller ensures that the request stays within system limits based on user status and available tokens. The student sees the available front-end chat assistants and decides to speak with the reflection assistant Robin. The Algorithmic Prompt Composer, APC, as part of operation control, creates a structured, data-backed prompt. APC defines the structure of the dialogue, determining which data is needed for the dialogue and what will be required for internal analysis later. It then passes the request to the qualified data retriever. The qualified data retriever determines which information is relevant in detail. It gathers details about the university, for example, that it is a German University of Applied Sciences. It retrieves context about the task, for example, from the official module handbook or the official learning script. It fetches course-related data, for example, that the course is about journalism, that the module economics has had 2 out of 9 sessions, and that the next session is tomorrow. It pulls relevant student-specific data, for example, first name, missed the last session, is bad at mathematics, and has the hobby football. The data source manager ensures that all data is retrieved from the best sources, including internal or external databases and documents. The APC uses this data to generate a professional prompt. Such a prompt can be 10 pages or longer and is written in a descriptive language well understood by the large language model. The multimodal model controller helps the APC determine which LLM is used and whether the response should be in text, image, or speech. Now it is time to pass the instruction to the large language model, LLM. A large language model, such as GPT, processes the request and generates a response. This is the only component in the dialogue that operates as an external black box model, meaning its internal generative process is not explicitly controlled or explainable by the AI architecture. The response is not given to the student directly. First, the response data splitter decides what part of the output is for the student and what is used internally. It parses the LLM response, splits it, and sends it on 2 separate output channels, separating control data from the dialogue. The output passes the user response analyzer, for example, to detect sentiment or evaluate a quiz answer. The split result for internal use is stored by chat metadata. It keeps relevant quantitative and qualitative insights, such as the evaluation of a quiz answer in the chat memory or the use tokens in the logging system. The split result for chat use is given to the critical content guard, which tries to identify biased or problematic terms like the word exam to prevent misuse or display predefined warning messages. Eventually, the well-prepared and double-checked answer is outputted and shown to the student. The front-end chat assistant awaits an answer, and the student enters new input. The compliance and policy checker ensures that the new request follows ethical and legal guidelines. For example, no use of offensive language or personal data like names or birthdays. Again, the user response analyzer checks how the student interacts with the LLM output. The sentiment analysis module detects whether the dialogue is perceived positively or negatively. The quiz evaluation module rates the student's effort, assigns it to the given question, and stores it. The data splitter parses the newly extended prompt. Some internal data is stored in the anonymous usage tracker. Other data is stored by the chat dialogue memory, which remembers key facts across all chat assistants. The long-term memory stores structured data, such as quiz results, in the database. The short-term memory temporarily holds details, such as personal preferences, for up to 30 days. Now, it is again time for the APC, as part of operational control, to decide whether new data is needed and how the next dialogue step should be planned. In every chat dialogue step, APC is involved again to ensure compliance and trustworthiness. Not to forget, the Orga admin access. The university admin can upload documents into the vector document store, along with suitable prompts. The initial vectorizing and searching within these documents is done by a local LLM specialized in this task. Course and institutional data are already stored in databases, but the admin can enhance them. Student data comes from existing campus management system databases. If external data is needed, the exchange protocol for qualified data attempts to fetch it. And that's how the AI system assists students in reflecting on their coursework in an intelligent, secure, and personalized way. By the way, this architecture is a suggestion, but it is also already in use. Except for the exchange protocol, most components have already been implemented, are in practical use, and are currently being optimized within the German project SMARTA. Thank you for your attention.